welcome back. I'm Lai. Do you guys know that there's a very important mission happening like today? Well, it's not going to happen today anymore because I just watched the launch and the mission was cancelled because there is some problem with the helium tank on the rocket. So it's scheduled for tomorrow. But anyways, this is going to be a very important mission in 2018 because we're sending for the first time the Parker Solar Probe to as close to the sun as possible. And if you think about it, there are so many things about the sun that we don't understand, which is totally unacceptable. So very quickly, I'd like to talk to you guys about this situation. I think I'll do it in 4 sections. I'll talk about its launcher, the probe itself, then its orbit, and lastly, I'll finish with the purpose of the mission because it's incredibly important that we understand why we're spending billions of dollars on missions of little immediate monetary return. Notice here I use the phrase immediate monetary return because I believe missions like this have tremendous positive implications and therefore benefits for our future generations economically or otherwise. Anyways, speaking of the launcher, most space lovers should know it. It's the Delta IV Heavy, second most powerful operational rockets in the world, right after Falcon Heavy. It is 72 meters tall and has a payload capability of 28 metric tons to the low Earth orbit. Besides this general information I've just explained, all you need to know is that the reason why NASA paid big bucks for this powerful machine is that unlike low Earth orbit missions, we're sending the probe to the sun, so the launcher has to be powerful to make it work. The probe itself has a dimension of 1 meter times 3 meters times 2.3 meters and weighs 685 kilograms. Comparing to a normal SpaceX payload, this is relatively small, but as I said, huge Delta IV Heavy is used because we are sending the probe to the sun. Instruments on the probe will do the following when it reaches its destination. I will not bore you guys with the technical terms since it's not necessary for the understanding of the mission. Just know that all of them are important for the success of the mission. Moreover, orbit of the probe is very interesting this time. Not only is Parker's solar probe going to orbit around the sun, the probe is also going to use Venus to perform gravity assist to slow itself down. Very interesting process. Many of you guys has asked me to explain it, so I'll talk about it briefly here. Basically, gravity assist is the usage of a planet's gravity to alter the path and the speed of a spacecraft. In the case of this upcoming solar probe, NASA will be using Venus to help lower solar probe's orbit so that as it makes more revolutions around the sun, it gets closer and closer to it. This chart from Wikipedia gives a good idea of what to expect in the next 7 years. For the uninitiated audiences, perihelion is the closest point of a solar probe around the sun. So after 26 total revolutions, Parker Solar Probe will be at the closest point 6 million kilometers away from the sun and at the furthest point 109 million kilometers from the sun. Every few months, Parker Probe will get really close to the sun and it has to take this opportunity to do measurements before it gets further and further away. At its furthest point, it will be as far away from the sun as Venus. Initially, it takes the solar probe 150 days per revolution. This number will decrease slowly to 88 days over the course of the mission. Now that we understand the orbits, it would be a good opportunity for me to come back to the probe itself. Remember the technical terms I refuse to talk about? With them, we'll try to understand 3 very important mysteries. 1. How come the temperature at Corona is higher than that at the surface of the sun? 2. How solar wind is formed? And 3. What mechanism causes occasional outbursts of solar energy? Unlocking these mysteries will not only help us understand the sun, it could also have real-life implications to our astronauts on their journeys to Mars. For example, the sun occasionally emits huge blasts of plasma arrays and paralyzes even electrical grids on Earth. If we do not understand how this was formed, it would be dangerous to expose our astronauts to such blasts when they are traveling to Mars in the next decade. Lastly, I want to talk about the heat shield because it's the most important piece of technology on Parker Solar Probe. Corona temperature of the sun could reach 1,371 degrees Celsius, and therefore it is incredibly important not to expose scientific instruments to sunlight. This is done through a heat shield called thermal protection system. Thermal protection system is a 4.5-inch thick carbon foam that is 97% air. Here is a video that demonstrates the capability of the material.
Here we have a piece of the heat shield for a Parker Solar Probe. It's very lightweight, as you can see. And here I've got a blowtorch, and I'm gonna use it to get the front surface of this glowing hot, and then we'll have a nice demonstrator come in and touch the back with his hand. So let's get this started. You can start seeing it glowing red. The real heat shield gets up to about 2,500 degrees Fahrenheit, which we're not gonna do today, but we are gonna get it to a couple of 100 degrees Fahrenheit. So it's going pretty good now. Curtis, why don't you touch the back surface of that? What does it feel like? Nice and cool, he says.
Well, pretty exciting stuff, isn't it? That's about it. I've explained what I have to say. 2 videos back to back. I'm pretty tired now, so if you have more questions, leave a comment down below or ask me directly on Twitter. I'll try to answer a few of those questions on Twitter, so definitely follow me over there. Lastly, I also like to thank, Joe, Lucas, and Dandai, as well as Chris. I think he supported me on Patreon just yesterday. Thank you all so much for supporting me on Patreon, and I'd really like to up my Patreon game very soon, so stay tuned. And yeah, that's it. As always, I'm Lei. I'll catch you guys later.